Hello, hello. Welcome back to Routers Part 2. We're going to be talking about plunge routers and a cool tip for setting their depth of cut. We're going to be discussing more about tear out and climb cuts, this time with a handheld router, and we'll also be talking about routing aluminum and much, much more. So stick around, won't you? All right, let's jump right in. Here I'm routing a 3/8 round over and all these pieces, and you're probably thinking, why not just take a long board, route a 3/8 round over, and then slice it up? Well, because one edge is 2 degrees, and so I'd have to make a 90-degree cut, a 2-degree cut, make a 90-degree cut, 2-degree. It just wouldn't be cost effective or time effective. This literally only takes a few minutes. Oftentimes, I find it easiest just to hold a router as if it was the router table, and if you have a small enough workpiece like I do here, to make the cut. Hey, here's a quick tip for you. So I'm using this chamfer bit. It's a 45-degree chamfer, and this area close to the bearing, it gets dull the quickest because I'm just barely using that one area. Well, what I've done is I've taken out the original bearing, which is probably this 3/8 bearing, replaced it with a 1/2-inch bearing, and so now in use, I'll be using a fresh part of this chamfer. I'm cutting these chamfers on these zero clearance inserts. This is Formica, and it dulls those bearings or the router bit really quick, even carbide. And so I can use a fresh area just by adding a larger bearing. Over the years, I've amassed a bit of a collection of router bearings. So with different bearings, you get a little bit more versatility with your router bits, yeah. Here I'm using a medium-sized plunge router, and this is one of my favorite tips for setting depth of cut by utilizing a drill bit. So I'm working on getting a breadboard end, and this tongue is 1.25 inches, but I need to sneak up on this distance here from the top to the top of the breadboard, and I know I need to go down another 3/64 of an inch. Now 1/64 of an inch is 16 thousandths, so 3/64 is 48 thousandths, and so what I've done, I've taken a feeler gauge, 26 thousandths and 22 thousandths for a total of 48. I can bring my router bit down so it just makes contact with the work. Lock that in place. Use this feeler gauge, put it between the turret and the plunge rod depth stop, and now I know that I'm going to travel down precisely 48 thousandths of an inch or 3/64 to obtain that perfect step height to match this breadboard end. It's quick, easy, and accurate. So I'm in the process of making these hidden drawers. These go under a toe kick, and you can't put a handle on them, and you still need a way to access that drawer front. So I made these little tab pulls, right? They're just made out of wood. And this little simple jig. So everything on here is 10 degrees, these cuts. These little pieces are really not necessary, but you'll see why in a minute. And anyway, this dude slips on here like so. I can clamp this in place, and then using a 1/2-inch bit and a 1-inch collar and a router, I route that out, and it'll make this recess for this dude dovetailed in there like that, and then that'll be accessible like that from underneath. Haha. Kind of different. And by the way, you might have noticed that little donut that I set the router on. That way the collar that hangs down below the router goes inside that little donut. Makes kind of like a cool stand. You know what I mean? And this may be well known, but this is the easiest way to get the depth when using a plunge router. Just use the hinge, or in this case, the handle, to get that depth just right. Okay, then the handles, I want to clean up these edges, right? So I made this 10-degree wedge. That guy goes on there, that goes against there. Using this Tico Vogt shooting board. I love this thing. It's phenomenal. And then I can just simply hold that like that, shoot the edge. Then I can flip it over, do the other edge. Of course, I need a little spacer, so I can just do that. Bam, same thing. Shoot that. And then this guy will go on here. That. course, that would have glue. There you go. Beautiful, nice fit. And then, of course, this would get flushed up after the glue dries. So, yeah. All right, so that last clip wasn't exactly router related, but it all ties in with the finished product. Here you can see this desk with top drawer, bottom drawer, middle drawer, a secret drawer, right? And ultimately, the one down below, hidden within the toe kick, and the recess created with a router. So what I've got going on here are some drawer box sides. Sides, fronts, and backs. And I just make length of this material. It's Baltic birch. It's edge banded with maple, about maybe 3/32 thick. And I glue that on with just woodworking glue. And then I route off the excess with a flush trim bit, right? Pretty standard stuff. If I have miles of this stuff, I'll just take it to a shop where they can run it through an edge bander and it comes out perfectly. But I didn't have that many to do, so I just did it by hand. And I wanted to show you a perfect example of tear out and climb cut and all that. So I wanted this to happen. I was going forward and you can see that this grain run out, it comes out this direction. And so as that router bit is spinning, it caught that and splintered it. So the climb cut will eliminate that. Let's try it again. Of course, I killed the sound here, but just running the router bit backwards, climb cut, reverse cut, whatever you want to call it. And that allows the bit to make the cut without catching that grain that's coming out at that shallow angle. And then you can make your last cleanup pass running forwards. So this is a really good example of where to use a climb cut. And it might seem like a lot of time to make those climb cuts, but it's totally worth it after you go through all the work of gluing the piece on, make a climb cut, and then you don't have any issues. Sometimes several climb cuts, whatever it takes. This has only been glued and taped. I routed it. It's probably been on here maybe 15 minutes. It is on there. You can see it's going to break the wood, so the glue is stronger than the wood itself. Very effective. So normally if I have a lot of routing to do, I will just take it outside because of all the sawdust that spews in the air and goes everywhere, But I thought I would try this little device, and it worked exceptionally well. It catches most of the dust with the vacuum. You can see it there. It's kind of a crude contraption, but hey, what can I say? It was very effective. You can see it's just a few pieces of Baltic birch, right, to capture that vacuum portion, and some sandpaper to hold it in place. So a question that I get asked quite often is, can I use woodworking tools, table saw, routers, to work with non-ferrous metals, aluminum, copper, brass? And the answer is yes, absolutely you can. As a matter of fact, I have a YouTube video on non-ferrous metals. I'll leave a link in the description. And a caveat or two about working with these types of materials is that you have to take it slow. There's a little bit of a narrower window as far as the speed. I always crank the speed down on my router as slow as it'll go, and then just take it really slow. Small, shallow passes, and you'll also see that I'm using WD-40. That helps tremendously. Now, of course, there are special router bits for aluminum, but I just used a standard straight bit double flute, and it worked fine. So here I'm probably going down maybe a 1/16 of an inch at a time and making lots of multiple passes, right? And a lot of oil. Stop, add oil. And there you have it. Let me get some air to this, blow that off. Check it out. Smooth, clean, beautiful, perfect. So here are a few jigs that I wanted to show you. This one is designed to follow a curved edge to create a dado, for instance. This was actually pretty specific, and that's what it was designed for. You can see how this hole is offset. The router bit came down through here. It's like a straight bit. This is just a bearing with a bolt. It's slotted in this piece of plywood, so I can move that to make my adjustment, and then that will follow a contoured piece, and I can create a curved groove or dado that follows that leg, for instance. And this line allows me, as I'm cutting, to keep that in alignment with the curved edge. Pretty effective. Well, we have this large router out. I'll show you. This is pretty simple. You can see how substantial this is with a piece of 1/4 inch here, a large hole for the router bit. This bolts to the base, and then with that, you could flush up some solid edging. Maybe you have 3/4 thick solid edging around a substrate, and you can drop the bit down. You have a lot of control. This rides on the substrate, and you can flush up your solid wood to the substrate pretty easily. Another jig that I use with this router, and actually this bit, is this jig. And with that, probably hard to tell in the video, but this is sloped 2 degrees. It fits this piece of wood perfectly. And with that, once this is in place, I can plunge this down to a preset depth, and it creates a little cavity for my little logo. Those are the logos that go on my DF500. It's nice and flush. It's a lot faster than a Forstner bit, and since plywood is different thickness, I can register that depth perfectly every time. If I'm at a drill press trying to use a Forstner and I have different thicknesses in plywood, which it varies, then my depth will be different. So this is a solution I came up with to not only make that depth the same, but make it quick and easy. So that one's for the DF500. The XL700 works the same way, right? This dude goes on there. These index top like so, and boom. Then with the same jig, I can put this extra piece in place. I can clamp this down, and with that, let me grab. So these are my vise wedges that I sell, and to put this logo in place, I do a similar situation. This is clamped to the router. I can put that in place, boom, drive it down, creates a little cavity. My inlay goes in there, so my logo goes in there. Kind of cool, yeah? This is just a simple fence for a small router. This would attach to here. You can see you've got this adjustment to get the fence close or far from the bit. Lock that down. Boom, very effective. Similar to this one on a medium size. Just lock that down. Adjustable fence. Yeah, man, awesome. All right, on to another project, and this is a bit of a unique design for a base plate. That bearing with the bolt going through it runs in a slot, and with that I can adjust the distance from the router bit to the edge of that bearing. Since these components are curved, I needed something to follow that curve, and this fit the bill perfectly. I simply marked the base, that way I would keep the orientation of the router and ultimately the distance exactly where I needed it to be. Right, so this dude will get a dado in it. I don't want to push that in, but it actually goes like this. No, like that. This will get a dado in it, and then a curved panel. Yeah, man. All right, so here at my router table, I'm putting a thumbnail profile on the top edge of these pieces of wood, and I have my fence here, but that's just for the vacuum. So I want to use a starter pin. You can see it, I've got it threaded in here. There's several positions on this. And the reason behind a starter pin is so that'll provide leverage as you bring the work into to make the cut. Of course, I just want that profile on the top edge. And if I was to just attempt this without that, the router bit could grab the work and force it around the corner. With the starter pin, it provides that leverage needed where I can ride against the starter pin and just make contact with about half of the bearing and then begin the cut. So there are probably a number of ways that I could create this thumbnail profile on the top of these backsplashes, but the router and the starter pin worked perfectly. So here you can see those subtle curved sides or those components, and all that was accomplished with a glorious router. So there you have it. I hope you got some good use out of this video, and as always, thanks a ton for watching.